Let me start with a question. What is the most frustrating thing about working with AI agents today?
That's a great question. The frustration often comes from having to manually prompt agents for every task, which is both time-consuming and limiting. You can't really let them work independently or compound their results.
Exactly, and that's where this repository comes in. What problem does it solve and for whom?
This repository solves the problem of making AI agents self-sufficient by turning them into loop engineers. It's for developers and engineers who want to build agents that can run on their own, perform tasks, and improve over time without constant human intervention.
So, it's a plug-in marketplace of skills for building loop engineers. That's interesting. Can you explain what a loop engineer is?
Sure, a loop engineer is an agent that can be triggered on its own, pick up work, execute it, verify the results, and log what it learned. This means the agent can operate independently, and the work it does can compound over time without needing human prompts for every step.
That sounds powerful. What makes this approach different from existing methods of working with AI agents?
The key difference is the loop structure. Traditional AI agents are task-based, and they require constant human prompts. Loop engineers, on the other hand, can trigger themselves, work on their own, and even update their knowledge base. This allows for compounding results across multiple agents working together.
Compounding results is a big deal. How does the loop structure actually work in practice?
It's built around a shared, file-based memory system. Each loop agent writes its findings and actions into a shared folder, and other agents can read from that folder to continue the work. For example, a support loop might log an issue, and a product loop could read that log and suggest a solution.
That's a concept I've heard before, but it's not common to see it implemented. What are the two main components of this repository?
The two main components are the Codebase harness and the loop engineering skills. The Codebase harness makes any repository agent-ready by setting up the infrastructure for agents to run, test, and verify their work. The loop engineering skills provide the scaffolding and template to create self-running agent loops.
I see. Let's dive into the Codebase harness first. What does it do, and why is it important?
The Codebase harness is crucial because it makes any repository ready for agent work. It sets up an isolated cloud box per agent, allowing loops to ship code in parallel. This means you can run multiple agents simultaneously, without them interfering with each other.
That's impressive. How does the Codebase harness ensure that agents can run, test, and verify their work?
It does this by providing a structured environment for each agent. Each agent gets its own isolated space where it can run, test, and verify its work. This isolation ensures that agents don't interfere with each other and that the code they produce is reliable.
That's a solid foundation. What about the loop engineering skills? What makes them unique?
The loop engineering skills are what make the agent loops self-sufficient. They include templates and tools for creating loops that can trigger themselves, perform tasks, and update shared memory. They also include tools for creating visual flow GIFs and setting up SEO growth loops.
Visual Flow GIFs. That sounds like a useful tool. How does it work?
The Visual Flow GIF tool takes an article, workflow, or architecture and turns it into a static PNG and an animated GIF. It uses a JSON specification to define the layout and then renders the result using Python and Pillow. This is great for creating visual documentation of complex processes.
That's a neat feature. What about the SEO growth loops? How do they work?
The SEO growth loops are designed to help with search engine optimization. They provide two playbooks, one for cold start SEO and another for existing sites with data. They include a loop template that can run on a schedule, making it easier to maintain and improve SEO over time.
That's a powerful use case. What are some of the caveats or limitations of this repository?
One limitation is that it requires some setup to get started. You need to install the plugin and configure the skills properly. Additionally, The effectiveness of the loop engineers depends on the quality of the prompts and the structure of the shared memory.
That makes sense. What are some of the key technical or architectural ideas that make this repository stand out?
One of the standout ideas is the use of a shared, file-based memory system for loops. This allows agents to communicate and build on each other's work. Another is the Codebase harness, which provides a structured environment for agents to run and verify their work in isolation.
And what about the plugin marketplace concept? How does that fit into the bigger picture?
The plugin marketplace concept is important because it allows users to easily add and install new skills. This means the repository can grow and evolve with new features and tools as they become available.
That's a great point. What are the implications of this for developers and engineers?
For developers and engineers, this means they can build more efficient and self-sufficient AI agents. They can focus on designing the right loops and sharing knowledge between agents, rather than manually prompting every task.
That's a big shift in how we think about AI agents. Who should really care about this repository?
Developers, engineers, and anyone interested in building self-sufficient AI agents should care about this repository. It's a powerful tool for those looking to create compounding agent loops that can operate independently and improve over time.